Welcome back. We are going to continue working with solving equations because the better we are at solving equations, inequalities will be easy peasy. So go ahead and pause the video, get that outline done, and come back when you're ready. Okay, so when solving equations, you are going to continue to see me come back to my sticky note. I like procedure. Do this, then do that, then do that. Every time you'll get it right. So I'm going to continue to come back to this process of distributing first, then combining like terms. Again, this is just like using the commutative property, and then isolating that variable, getting it by itself. And we do that by using inverse operations. Okay, so let's look at our first equation. Negative 2/3 a equals 18. I should probably move that over. Okay, negative 2/3 a. What operation is going on there that we have to undo? Because I don't see any distributing. I don't see any like terms on this left side. So negative 2/3 a, that's the only thing with our a. So that's what we got to get rid of. How are we going to do that? Negative 2/3 a. Okay, so what's the operation? Negative 2/3 times a. All right, so we're going to be dividing both sides by negative 2/3. Now, there's a couple ways that you can do this. I have some people that like to rewrite it and they put their a with the numerator. So it says negative 2a divided by 3. So they undo the division, then take away the 2. Well, divide by 2, not take away. Or we can do it all in one step. Because remember, whenever you are dividing by a fraction, so dividing by the 2/3, essentially that's the same thing as multiplying by its reciprocal. So to get rid of it all at once, I'm going to multiply by negative 3/2. It doesn't matter where you put the negative, just go ahead and attach it to either the numerator or the denominator. Because this would cancel out my 3's and cancel out my 2's, and a negative times a negative is a positive. Whoa. Sorry. So we're just left with a. So again, why do I draw my line? So I don't get so excited that I forget to do it to the right side. So when I multiply, I'm going to go ahead and cross simplify. So 2 goes into 2 once and into 18 9 times. So now I have 9 times negative 3. A equals negative 27. Well, let's try it out. If we have negative 27, if I were to plug back in, I'm going to attach this negative to the 2. So negative 2 times negative 27 gives me 54. 54 divided by 3, 18. Awesome sauce. All right, so a equals negative 27. Oops, I didn't read directions. This told us to solve each of the following and list the properties used. So I used the multiplication property of equality. So I'm just going to use POE for property of equality. So I use the multiplication property for equality. There is another way that you could have done this that would have taken 2 steps, and that would have used 2 different properties. Totally fine. Okay, so let's try the next one. 4y plus 3 equals 18. Okay, so 4y plus 3 equals 18. What are the operations that we need to undo? So there's no distributing to do here. If I look at the left side, there are no like terms. So 4y and a positive 3, those aren't the same, can't combine them. So we just go to isolate. So what do we need to undo? What do we need? What inverse operations? So I have a plus 3 that I need to get rid of, and 4, what's that operation again? 4 what? 4 times y, so we got to undo a multiplication and an addition. So PEMDAS in reverse, I'm going to start with addition and subtraction. So plus 3, I am going to subtract 3, so that's my subtraction property of equality. And I get 4y equals, that cancels, 15. Awesome. Now what? So again, 4 times y, we are going to divide both sides by 4. Okay, just check my work. So y equals 15/4. And we use the division property of equality. Feel free to simplify, that's totally fine with me. So y equals 15/4. Alright, so if I plug that in, because I want to check my work, 15/4. I want you guys to see what I'm thinking over here. So, hey, I got 4/4. So those cancel. 15 plus 3, that does equal 18. So it looks funny, but it definitely works. When you end up with an improper fraction, leave it as an improper fraction. In algebra, there is very rarely a chance when we will ask you to change it to a mixed number. Improper fractions are what we would like you to stick with, okay? So I don't know why in elementary school they stress for you guys to change it to mixed numbers. In algebra, improper fractions all the way. Why? Because when we plug it back in, it usually helps us to simplify it a lot easier. Alrighty, let's try the next one. 8 equals 1/2 times m minus 1. Ooh. Alright, let's try it out. So 8 equals 1/2 m minus 1. Look at your steps. What always comes first? You guessed it. We're going to distribute. So let's distribute this 1/2. So distributive property. So we end up with 1/2 m minus 1/2 equals 8. Okay, no big deal. So now what do we have? So we have a 1/2, draw my line, so 1/2 m, or 1/2 times m, minus 1/2. So PEMDAS in reverse. Let's undo any addition and subtraction. So we're going to go ahead and add 1/2 to both sides. Again, we are using the addition property of equality. So 8 plus 1/2. Please don't write 8 and a half. No mixed numbers. We're going to keep it improper. So 8 is how many halves? 8 is, if I multiply it by 2/2, that gives me 16 halves. So 16 halves plus 1/2, I have 17 halves. And you're going to see why I do this in a second. Equals 1/2 m. Or like we were saying, 1/2 times m. Alright, so now I have two things I can do. 1/2 times m. So I can divide by 1/2. And remember, dividing by a fraction is the same by multiplying its reciprocal. So I can also multiply by 2/1 because that'll cancel that. So if I multiply this by 2, now do you see why I left it as an improper fraction? Those cancel. So m equals 17. And don't forget to list your property. We multiplied each side by 2, so we use the multiplication property of equality. It would be correct if you said division property of equality, because we could have divided by 1/2, which essentially it does the same thing as multiplying by the reciprocal. So both of those would be appropriate answers. So m equals 17. Let's try it out. 17. If I plug back in, 17 minus 1 is 16. Half is 16. That's 8. Just a quick, easy check. Alright? Okay, on to the next one. Let's see, orange. So 7 minus the quantity. What was it? Y minus 2? Yep. Y minus 2 equals 7. Okay, so let's come back to those steps. First thing I want to do is distribute. Now, what am I distributing? What is touching the parentheses? Just the negative sign. So what is that? Negative what? negative 1? Yeah, so now we have a negative 1 to distribute to both terms. So we've got 7, and then negative 1 times y gives us negative y, or negative 1y, however you want to write it. And then negative 1 times negative 2, positive 2. Those signs are super important. Equals 7. So far, so good? So first we use the distributive property. And now, let's combine like terms. Are there any like terms on the left side? Yes, there is. There's a 7 and a positive 2. So 7 plus 2 would give us a positive 9. So we have negative y plus 9 equals 7. And by combining those like terms, essentially we could have rewritten it negative y plus 7 plus 2. So that would have been using the commutative property. So yes, occasionally we do use the commutative property. Most of the time we just do it in our heads, so we don't actually write it out. We don't realize we're doing it. So negative y plus 9 equals 7. PEMDAS in reverse. Let's get this y by itself. So undo this plus 9. So we are going to subtract 9 from both sides by using the subtraction property of equality. So negative y equals 7 minus 9, negative 2. Don't you tell me that that's the answer, because I don't want to know what negative y is. I want to know what y is. So remember, what is in front of that? A negative 1. So I'm going to divide both sides by negative 1. And y equals negative 2 divided by negative 1, positive 2. So we use the division property of equality. And check it back. 2 minus 2, 0. 7 minus 0, yep, still 7. So it works. All right. So there we had 4 different steps going on. Again, was that process super difficult? It's not that bad. Just take it one piece at a time. So I'm going to go ahead and make a note. If we ever use combining like terms, that is essentially using the commutative property. Okay. Alrighty. Oh my gosh, so many questions. So I gave you guys a lot of examples. If you're comfortable, you can skip a couple. Better have these 4, and then if you want, you can skip onto the challenge. It's completely up to you. I'm just giving extra examples in case you need them to look at. So 6n plus 21 equals negative 3 minus 2n. Okay. No, I don't see anything to distribute. There's no parentheses. So if I look at the left side, 6n plus 21, like terms? Nope. How about the right side? Negative 3n and negative 2n. Not like terms. Okay. So what we need to do is we need to get all of our variables on one side and everything else on the other. Now there's more than one correct way to do this. So when I look, I say, okay, which side has the most, in this case, n's? So I have 6 n's and negative 2 n's. All right, positive 6 is definitely more. So to keep my answer positive, I'm going to go ahead and move this 2n over with this 6n. So what is the opposite of a negative 2n? Positive 2n. So we just use the addition property of equality. So that gives me 8n plus 21 equals negative 3. All right, now all of my variables are on the left side. Again, if you would have moved the 6n over, you definitely still could have gotten the correct answer. I just like to try and keep my variables positive if I can. All right, so 8n plus 21. So let's go ahead and undo this plus 21. So we'll subtract 21 from both sides. by using the subtraction property of equality. So negative 3 minus 21 gives me a negative 24. And I bring down my 8n. So remember, this isn't just 8n, this is 8 times n. So how do we undo it? Yep, divide both sides by 8. So n equals negative 3. So let's plug it in and check. 6 times negative 3, negative 18. Negative 18 plus 21 is 3. So let's plug it in over here, negative 3. So negative 2 times negative 3 would be positive 6. And negative 3 and a positive 6 would also give us 3. So does 3 equal 3? Yes, it does. Okay. Again, oops, I forgot to list that last division property of equality. I have a lot of people who fight me on plugging it back in and checking your work, but how simple and easy is that to make sure, especially in a testing situation, that you've got the correct answer? All right, this next one is a pretty good one. 8 times the quantity 2w minus 1. Geez, this might be the challenge. 8 times the quantity 2w minus 1 minus 4w equals negative 116. All right, so when we look at this, we got a lot going on, so take it piece by piece. What always comes first when we're using those steps? Distributing. So I'm going to go ahead and draw my line down that equal sign. I don't want to mess anything up. I got a lot going on this time. So if we go ahead and start with distributing, we are going to distribute that 8. So 8 times 2w, 16w. 8 times negative 1, negative 8. Then I'm going to bring down the rest, minus 4w equals negative 116. All right, so we just used the distributive property. What's next? Are there any like terms? Well, if I look, I got a 16w and a negative 4w. So that leaves me with 12w minus 8 equaling negative 116. So I just used the commutative property. Okay. And let's see, what next? So I'm going to undo this subtraction because I want to do PEMDAS in reverse when I'm trying to isolate that w. So we are going to add 8. Cancel it out with the addition property of equality. So negative 16 plus 8, negative 108 equals 12w, and divide by 12 using the division property of equality. W equals, don't forget about this, negative 9. Yep, 99 plus 9, 108. Awesome. All right, a little bit more of a pain, but I do still want to plug in and check my work. So if I plug in a negative 9, 2 times negative 9 is negative 18. Negative 18 minus 1 is negative 19. So negative 19 times 8. So 80 and 72. Well, I'm going to have to write this off to the side. So 8 times, we said negative 18 minus 1 is negative 19 minus 4 times negative 9. So we got negative 152 plus 36. Bum-ba-da-bum. It does give us negative 116. That's pretty positive, but I still like to check myself, make sure I didn't make any little silly arithmetic errors on the way. All right. So if you want another one, let's go ahead and look at this challenge problem. C minus 3 plus 4C equals 3 times the quantity. I believe that said 3C minus 9. Let me go back and check. 3C minus 9, yes. Okay, perfect. All right. Clock going on. That was not much better. I give up. Okay, so want to get this left side, right side. Let's go ahead and simplify. So on the left side, what can I do? Let's see. I have a C, I have a negative 3, and a positive 4C. All right, so my like terms, 1C plus 4C gives me 5C minus 3 equals, okay, all right, I'm going to go ahead and look at my right side. I'm kind of doing too much at one time, but I want to go ahead and simplify this because I can clearly see I need to distribute. So 3 times 3C, 9C, 3 times negative 9, negative 27. So I essentially just did two things at once. I used the distributive property on my right side, and I used the commutative property when I combined like terms on my left side. All right, now I've gotten rid of distribute and combine like terms, so we are going to isolate. We need all our variables on one side. So again, for me, I like to look at it and say, where are there more? So I have 5 C's on the left, 9 C's on the right. So since I have 9 C's on the right, I'm going to bring all my C's to the right to keep them positive. So what's the opposite of a positive 5C? A negative 5C. So I'm going to use the subtraction property of equality to bring that over. So subtract 5C from both sides. So we've got 4C. Then I've got a negative 27 over here and a negative 3 on the left. So all of my variables on the right, so everything got to get moved over to the left. So that negative 27, the opposite, positive or plus 27. So we're using the addition property of equality. So if I add 27 over here, 27 minus 3 leaves me with 20. Oh, so 24 equals 4C. Or 4 times C, so inverse operation. We're going to go ahead and divide by 4. So we use the division property of equality to get a solution that C equals 6. And if I plug back in, 6 minus 3 is 3. Then I got 4 times 6 is 24, so 3 plus 24, 27. Hopefully I did that right. On the right side, 3 times 6 is 18, 18 minus 9 is 9, 3 times 9, 27, 27 definitely equals 27. So just a quick check at the end. Okay, so that's all kinds of solving examples that you got. And then we listed those properties to make sure we can prove why we're doing it. All right, now we have two types of special solutions. So I want to show you these in case you're simplifying something and your answer looks a little wonky. So 3n plus the quantity of plus 6 times the quantity of n minus 1 equals 9n minus 6. Okay, so what I want to look at, 3n plus 6 times n minus 1. So I definitely have a positive 6 to distribute. So I'm going to go ahead and start with that. Solve these just like normal. So I've got a 6n and a negative 6. Don't forget to bring down the 3n and your 9n minus 6. Okay, so we use the distributive property. Now we're going to look at to see can we combine any like terms. So on the left side I have a 3n and a 6n. So we have 9n minus 6 equals, and then 9n and a negative 6. Those are not like terms. So we just keep them. So we use that commutative property to combine like terms. Now let's see. I'm going to get all my variables on one side. So I have a 9n and a 9n. What? A 9n and a 9n? Well, if I cancel out one of them, so positive 9n, if I subtract 9n from both sides, they both go away. So we use the subtraction property of equality, but what the heck happened? We end up with negative 6 equals negative 6. Is that a true statement? Does negative 6 in fact equal negative 6? Yes, it does. So what does that mean? Infinity. There are infinite solutions. I can pick any number, negative 5,828, and if I plug that in on my left side and I plug that in on my right side, my left side will always be equal to my right side. That's what that means. So if you simplify and you get something, a true statement like negative 6 equals negative 6, or x equals x, or 3x equals 3x, or 5 equals 5, you catch my drift? Anything that's true, it is going to be infinite solutions. All right, now there's another funky one that has a special solution. So let's look at 4n minus 3 minus 5n equals 6 minus n plus 4. Okay. I don't see any parentheses, therefore I don't think there's anything to distribute. So let's look at combining like terms. So on my left side, I have 4n and negative 5n. Okay, so negative 1n minus 3 equals, let's see on the right side, we got a positive 6 and a positive 4. So 10 minus n. So we use the combining like terms, so we use the commutative property. And now let's get all our variables together. So I have a negative n and a negative n. All right, so something weird is going to happen again. So if I cancel this out, so if the opposite of a negative is a positive n, which cancels out both of these, I end up with negative 3 equals 10. Does negative 3 equal 10? No. Is negative 3 ever going to equal 10? No. So this is a no solution. There is no number on this universe that we can plug in that will make the left side equal the right side. It is not going to happen. So no solution. The symbol for that is a 0 with a slash through it. Oh, let me go ahead and write in my addition property of equality. All right, I know that was a lot of examples, so go ahead and take a breather, take a stretch break before you start working on your own. Have a great day.